Hello and welcome to York Observatory's monthly TeleTube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Ellen Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube now broadcasts every last Friday of the month at 7:30 p.m. Eastern Time. For any questions or comments you have of our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory and Facebook at Allen I. Carswell Obs. Good evening, everyone. I'm Camila, and I'll be one of your hosts this evening, along with Zena and Paul. We are here from the Allen I. Carswell Observatory at York University. Tonight, we got a special guest speaker, Nakul Sethuram, who will be talking about the physical characteristics of Venus. Before we start, I would like to mention that the observatory at York campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Toronto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous people. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. I will now hand it over to Paul so he can tell you all about what's up in the sky this week.
Hello, everyone. My name's Paul. I'm a first-year student at York University in the astrophysics department. I want to tell you about what's up in the sky tonight. And I looked out a little earlier and it was clear, and I hope it stays that way for people to get out and take a look out tonight. This is an image of what the sky should look like from where I am, which is Newmarket, Ontario, just north of Toronto. And as you can see, the moon is nearly full. You can see that in the image, and it's very, very close to the planet Jupiter, which totally dominates the night sky. It's very bright right now. It's near opposition, which means it's on the opposite side of the Earth from the sun. And that means as the Earth turns, it rises at sunset and sets at sunrise. So we have it for most of the night. Also in the night sky is Saturn, lower in the sky and not really as dominant as it was earlier in the year, but still a great sight, particularly if you have a small telescope. You can see the rings and it's quite lovely. We're also starting to see the winter constellations. And if you notice in the upper right part of the image, there's just a hint of three little stars sort of at 45 degrees in this image. I'll come back to that. But that is the belt of Orion. Go to the next slide, please. So what's up in December? Well, planet Jupiter, with respect to planets, Jupiter will dominate the night sky. Saturn is still absolutely viewable. And Venus, if you're an early riser, as am I, if you go out early in the morning and it's clear, you'll see in the eastern sky that Venus totally dominates the sky. It's very, very bright. It's much brighter than Jupiter. In fact, Venus can get so bright, sometimes it can be seen in daylight or even cast a shadow. So you'll very much notice this bright object in the eastern sky, quite high up, and that would be the planet Venus. Mercury is also making an appearance. Now, Mercury is visible to the naked eye, but it's a very difficult planet to see because it's usually so close to the sun. But in December, it's making what's called a greatest elongation appearance. And what that means is the distance from it to the sun is is greater from our perspective. So if you were to go out in the mid-morning sky and wanted to find Venus, it'll still be quite close. Sorry, Mercury. It will still be quite close to the sun. But if you think about, if you sort of make your fist and point at the halfway point between the zenith straight up and the horizon, that's 45 degrees. Half that again, and you're at about 24 degrees. Well, Mercury is at 21 degrees. It'll be bright, but not nearly as bright as Venus. But you should be able to see it. You should get a good visibility. It also moves very quickly. So you've only got a day or two around greatest elongation to see it. And I would suggest you do a little research online. It'll give you some hints on how to find it. The moon is just past full at the beginning of the month, but this is really exciting because we're getting a great Christmas present this year. Christmas Day, the moon will be full again. Happens every 28 days. So we'll have a beautiful moon on Christmas Day. And also the constellations Orion, and Taurus are going to be making their winter constellations, and they're going to be making a great appearance. And they both have nebula in them that are near visible to the naked eye, or nearly visible to the naked eye. The Great Nebula in Orion and the Pleiades in Taurus. So how do you find Orion and the Pleiades, the Orion Nebula and the Pleiades? So on the left here, I've got an image from the Vatican Observatory, and it shows a bunch of stars. But if you'll notice, on the left side, about halfway through the image, there's 3 stars in almost a straight horizontal line, 3 quite bright stars. And above them is another bright orangish star, and then below them is another star as well. That's the constellation of Orion. And Orion is the hunter. You can actually see that you've got those 3 stars. That makes his belt. And above it is that bright orange star. It's called Betelgeuse. And that is one of his shoulders. And kind of at a diagonal coming down from that, you've got another star there that is another shoulder. And then below the belt, you can see 2 stars representing kind of his hips or his thighs. And then underneath the middle star in that belt, there's kind of a straight line of stars coming down, which would represent the sword of the hunter. And that's where you can look for the Great Nebula in Orion. To the naked eye, the bottom of those stars is kind of fuzzy. If you've got good skies, you can see it's definitely not solid. It's kind of a fuzzy object. In binoculars, this is extremely clear that it's a fuzzy object. And in a small telescope, it starts to take on a shape. And you can see here in the upper right image, that is the Great Nebula in Orion. And that's where it is. It's located in the sword of Orion, underneath Orion's belt. And it's actually a fascinating object. A lot of people, a lot of amateur astronomers consider it, the best thing to look at with small telescopes or with binoculars. It's very bright. It's got a beautiful pattern to it. Some great colors start to become visible in telescope. And it is actually a stellar nursery. It's a birthplace of stars. There are stars being born in it. As you look at it, you won't, it takes a very long time. Stellar birth is a long process, but that is a big cloud of gas with stars being born in it. Now, it's a bit of a lost art, but, when I was a young man, which is quite a long time ago, we used to use Orion's belt to navigate our way around the night sky. So again, go back to the image on the left and take a look at Orion's belt. And imagine it's pointing kind of in a straight line to the right. Follow that line over. You're going to go past another bright orangish star. And then you're going to come to this little clump of 5 stars. Some people see 5 stars, some people see 4, some people see 7. And if the skies aren't great, it's just going to be kind of a fuzzy area. But if the skies are good, you will definitely be able to make out a number of stars. That's the Pleiades. And again, we have that in the lower right image. And that's also a group of stars early in their life. And there's a lot of stray gas around them and so on. But it is what's called an open cluster of stars. it's very visually beautiful in binoculars or in a small telescope. The bigger the telescope, the less satisfying it is to look at, ironically, because the stars are relatively far apart. I'd also like to point out in between Orion's belt and the Pleiades, there's that bright orange star again. And that, if you look at it closely, you can see it sort of makes a V shape with a bunch of stars. That's the snout of Taurus the bull. And it's actually a very interesting object to look at. But Orion and Taurus dominate the night sky in the winter. And if you go outside and it's not cold and you wonder what season it is, I mean, I'm sure you know what season it is, but if you can see Orion or Taurus, you know it's winter. And with that, I wish you good observing, and I'll turn this back over to my colleagues. Thank you very much.
Thank you so much, Paul. That was very informative. Everyone, please join me in extending a warm welcome to Nakul, an invaluable member of our observatory crew. Nakul is an international student from India. He is currently in his third year of undergraduate studies. He joined the Physics and Astronomy program at York University in 2021. And his journey at the Alan I. Carswell Observatory began in 2022, where he has seamlessly woven his expertise into both paid and unpaid roles. He's a certified 1-meter telescope operator, as well as an engaging and enthusiastic tour host who is always more than ready to explain the wonders of the universe. He finds planetary science and exoplanets fascinating. His curiosity led him to be more and more interested in the hunt for signs of extraterrestrial life. In his free time, Nakul finds solace in stargazing and listening to music. He also enjoys writing and traveling around the globe. Nakul, the floor is yours.
Yeah. Hello. Thank you so much. Let me just share my screen now. Yeah. Can you please see my screen? Okay. Great. So hello everyone, I'm Nakul and I'm doing my third year in Physics and Astronomy at York University, and I'm really glad to join for today's TeleTube. And my topic about today is gonna be the physical characteristics of Venus. And before starting, I would like to thank Professor Elena Hyde for giving me this opportunity to be a part of this TeleTube. And also I would like to thank the TeleTube crew for tonight, Camila, Zena, and Paul. And also I would like to thank Professor Sarah Ruheimer because she's inspiration for me doing this topic. And yeah, let's get into the Mars exploration of Venus. I'm so excited. So what are we gonna cover today? It's gonna be so fascinating and amazing, of course, yeah. So we will be covering about the atmosphere and the climate of the Venus, and a runaway greenhouse effect, which tells why Venus is so hot. It's like the hottest planet in our solar system. Detection of phosphine is something really interesting. It's related to the detection of life in the Venus. And the topography of the Venus, volcanoes and craters tells the geology of the Venus, and the internal structure of Venus and the magnetic field of Venus is also another interesting topic to go over. Before starting, I would like to give a small introduction about our planet Venus. So Venus is the second terrestrial planet from our solar system, as we know from our sun. So, and also it's the hottest planet, and it's being hottest is because of the high presence of greenhouse gases, especially the CO2 in its atmosphere, which literally traps the heat. And this is something interesting for me. It's similar to Earth's size and mass. So when we go say the similar size is basically like the planet, it's like has similar diameters, like the difference between the diameter of planet Earth and the Venus is just like around 600 kilometers, which is good. Like it's not a big difference. and it's like 82% of Earth's mass, and also its gravity and its escape velocity is similar, but just Venus is a bit lesser than the planet Earth, and rotational period is higher than its orbital period. So the rotational period is basically like it's rotate on its own axis. It takes like around 243 days for Venus, and its orbital period, which is like basically revolves around the sun, it takes like 225 days, and it's something so kind of a mystery. And this could be maybe due to the atmospheric situation, because the atmosphere of Venus is so denser, or it could be maybe due to some collision happen during like its evolution or something, but it's still being a mystery. And also the other mystery of Venus is it undergoes retrograde motion, which means it literally, as we know, most of the planet uh, rotates from west to east, where the Venus rotates from east to west, which we could able to say the sun rises in the west and sets in the east, which is completely opposite than to our planet Earth. And the last one doesn't have any moon, so on the skies of Venus, this is only like we don't. It doesn't have any natural satellite orbiting it. And yeah, we are gonna go over the atmosphere of the Venus at first place. So the atmosphere of Venus. So the atmosphere of Venus consists of dense carbon dioxide, which is 96.5%, followed by nitrogen, which is like around 3.5%, and also along with some other elemental gases, which include sulfur dioxide, water vapor, argon, and helium, hydrogen, and goes on. And also its surface temperature is higher because of the greenhouse gas. So typically the greenhouse gas are good at trapping heat. So since the atmosphere of CO2 is like highly filled with CO2, it is actually a strongest element in trapping heat. So since it traps heat, so it's because of its presence, it's like literally like heating up the planet, and that's why it's the hottest planet in our solar system. Sulfuric acid clouds. So we'll be going over it again later in our later slides. And discovery of phosphine, a potential biomarker. That's also interesting, and we'll be going over to it again as well. Exhibits atmospheric superrotation. What does basically mean by like the rotation of the atmosphere, Venus atmosphere is way more faster than the planet's rotation. So it's technically means like due to the extreme winds in the atmosphere of Venus, let it to rotate faster than its planet. So, and also it takes like around 4 Earth days for the Venus atmosphere to rotate, compared to its planet's rotation, which is like around 243 days, which is like a way too difference. The next one is the temperature. So, as I mentioned before, the presence of greenhouse gases led to the increase of surface temperature, which is why the Venus is so hot. And the surface temperature is like around 737 Kelvin, which is good enough to melt the lead. And also, if you could able to see on the graph, you could able to see the temperature decreases as the altitude increases. Like you could able to see on the graph from 0 to like around 60 to 670 kilometers, it actually constantly decreases. And then because it's a troposphere, that's where the greenhouse gases have been present in a high amount. And then if we go like from around 80s to 120s, the temperature like stays less and constant, which is basically meosphere. Meosphere is basically like it always stays cooler because there isn't any absorption of heat or like trapping of heat happens there. And then if you just go like over 120 kilometers, you could able to see the temperature slightly increases. It's basically like that's thermosphere and exosphere, and that's where a lot of solar radiations and trapping as well takes place. And the temperature is constant everywhere in the Venus. It's basically of the transfer of heat. So the heat in Venus, so it literally like transfer everywhere across its planets due to the effect of thermal inertia, and that's why the planet is maintained at the same, almost not kind of almost at the same temperature. And the increase in greenhouse gas, it's because of the runaway greenhouse effect, and the next one we are going to see about it. Runaway greenhouse gas effects. So as we know, as I mentioned before that, the planet Venus has similarities with planet Earth. So it was actually. So the billions of years ago, like how we have water, so Venus also had water. So what happened as the years passed? So the luminosity of the sun increased. So increase in luminosity led to the increase in the temperature. So increase in temperature led to the increase of evaporation of water in the Venus at a large scale, which means the rate of evaporation was so higher, and also it just like started to evaporate fast, like it doesn't stop at a constant pace. So the evaporation level was so higher altitude. So, and also the Earth's Venus magnetosphere is way weaker, so which led the UV rays from the sun and from the solar wind let the interact with the water molecule in the atmosphere. So the H2O molecules was dissociated into H and O2, whereas the H molecule escaped from the atmosphere because the escape velocity of the H molecule is very less, and the O2 molecule got combined with the O2 molecule was dissociated like two, because it's two molecules like dissociated into a single oxygen molecule, which combined with the carbon monoxide, which was emitted from the volcanic activities. So it just combined with the carbon monoxide there, which led to the formation of carbon dioxide, which is actually the greenhouse gas. So this is what happened at a very high scale level. So that's why Venus lost all of its water, and all of its water became a carbon dioxide today. And if we use a similar situation for our planet here, if you ask me whether it happens, yes, it does happens. If the carbon dioxide level increases, of course, so it increases in temperature, and that leads to the extinction of life, probably. Maybe like some state of life might survive, but most of the life might face extinction. Clouds, precipitation, and climate, and how the Venus basically looks like when it's come to climate, precipitation, and clouds. So Venus clouds are so thicker, denser, and mostly composed of sulfuric acid. And how does it happen basically? So as I mentioned before, due to the dissociation of evaporation of water, so the sulfur dioxide was evaporated from the volcanic activities, which later combined with the water molecules in the Venus surface, in the Venus atmosphere, which later formed into sulfuric acid. So sulfuric acid precipitation happens in Venus, and it's like way bit different. So it doesn't like the precipitation doesn't, the water droplet doesn't, I mean, the acid droplet doesn't hit the ground, I mean, the surface, before it reaches the surface, it becomes like into gas again, and then it just goes up. So this is basically called as dry storm. And also the Venus clouds reflect 70% of the sunlight, and only 10% of the sunlight receives the planet, which means the planet's like way darker. And also Venus doesn't have no seasons. It's basically because of its improper rotational period, and also its orbit is not elliptical, like not completely elliptical. It's like more closer to like circular. So that's why Venus doesn't experience any seasons. It's just basically like just increase and decrease in temperatures. Next one is my favorite and most coolest one, phosphine in Venus. So phosphine is a biosignature gas which basically like produced by the life. So if there's a detection of phosphine, which mostly tells us that there could be some existence of life, could be like in any form, could be like a microbial or maybe like in a large scale, like how it's like in planet Earth. So phosphine is like a one of the important gas which tells whether might be, maybe not, life exists or not. So recently, very recently, like in 2020, there's a detection of phosphine happened, which created a debate over the possibility of life in Venus. But what's the problem with Venus is basically like Venus is so acidic planet, and also the possibility of life in Venus was too low. But since the detection of phosphine created a debate among scientists, debating over whether there would be some existence of life or not, and where would be probably the existence of life would be. So it's technically not on the surface, but it'll be like somewhere between the clouds. Like if you could able to see on the image towards your left bottom, you could able to see there's a temperate zone where the pressure is 1 and the temperature is like reasonably 60 degrees Celsius. And that's where it's suspected that there might be some microbial activities or any kind of life formation might be expected, but also it's not determined yet. And it could be either the first man, maybe like could be either from some unknown chemical reactions. It could be like either meteor, maybe because of meteors or lightning or like volcanic activities or like maybe from surface mineral. So that's why there's a big debate is going over it. And yes, and one most coolest thing about is the NASA is coming back to Venus after 50 years. As we know, NASA's like most focusing on Mars these days. Now they're coming back to Venus after the detection of phosphine. So they are planning to launch 2 missions. One is the Deep Atmosphere Venus Investigation of Noble Gas, Chemistry and Imaging, DAVINCI+, and the other one is Venus Emissivity, Radio Science, and Topography and Spectrography, BERITAS, and these 2 missions are expected to be launched maybe within this decade. But yeah, so NASA's interest is going towards Venus, and we might hope, if anything, if there's any detection happens, and that would be like a huge milestone towards the detection of life in the planet. And the next one is the geology of the Venus. So how does the Venus looks like and its surface and everything. So that's what we're going to see next. So the topography of the Venus, it says like the 80% of surface is covered by smooth volcanic plains and bare rocks on the Venus. And the surface of the Venus, which is based on the altitude, is determined into three types. One is highland. Highland is basically which has an altitude greater than 2 kilometers. And also highland is more rich in dielectric materials, and deposition plane is like between 0 to 2 kilometers, and the lowland is less than less than 0 kilometers. And in Mars, we have like three highlands. One is Ishtar, Aphrodite, and Lada. So Ishtar is it's in the northern hemisphere, so it's almost like a size of Australia. And at the Ishtar, that's where the highest peak of Venus located, which is Maxwell Montes, is like around 11 kilometers. Yeah, of course, it's greater than the Mount Everest. And the next one is Aphrodite, actually the largest highland, and which is like a size of South America. And the last one is Lada. Lada is the low-lying highland, which is like in the southern hemisphere. And next one is the volcanoes and the craters. So there are like more than 85,000 volcanoes identified in Venus, which is like highest of any planet in the solar system. And it has like shield volcanoes, pancake domes, and lava flows kind of volcanoes. And also there was a question of how there would be tectonic plate movements in Venus, like when we look for our planet Earth. There was a possibilities because most of the surface, like the surface area of Earth, has water, but whereas due to the Venus, it's like completely a dry and a rocky planet. And how does those tectonic plates movement and the formation of rocks and mountain happen, which is reason behind it's the volcanoes pressure, which led to the tectonic plate movements and the formation of mountains, rocks, and other like creations like in Venus. So that's the reason. And also Venus has few crater impacts, and which are like really great one, because the smaller meteor impacts, like it just like get burned before it reaches the surface, as we know the surface temperature is so higher. So Venus has like the great crater impacts, which like range from 3 kilometers to 80 kilometers diameter. Next one is the internal structure and the magnetic field of Venus. So internal structure of the Venus is basically similar to our planet Earth, which has a crust, core, and mantle. So the crust is basically made up of silicate rocks, and which has thickness of like around 70 kilometers. And the mantle is composed of granite, which is 3,000 kilometers thickness. And the core is made up of iron and nickel, which is again 3,000 kilometer in thickness. And also the core, when we compare to Earth's core, the core of Venus is in semi-solid state, whereas in Earth it is in solid state. It's because due to low pressure in the core, which led to be on a semi-solid state. And the last topic for today is we're going to cover is the magnetic field. So how the magnetic field in Venus get formed? It's due to the interaction between the ionosphere, which is the almost the farthermost layer of the Venus atmosphere, and the solar radiation. So the magnetic field which has been formed due to the interaction of ionosphere and the solar radiation gives a poor protection. So what this basically means is like if a planet has poor magnetic field, which led to the solar radiations and the other solar wind to enter uh, the atmosphere. And if I just bring the runaway gas, greenhouse gas effect topic, so just so due to the poor protection over the atmosphere, which led to solar radiation like UV rays, led to the interact with the water molecules and also with the other elements, which result in dissociation and then led to the formation of which led to the formation of huge amount of CO2, which is dominating in the atmosphere right now, and which was the reason for its high temperature. So, and also the weak magnetic field is because of the lack of convection in the outer core, which is basically like, again, since the core of the Venus is in semi-solid state, so there's a lack of convection. So, I mean, the convection still happens, but it's due to the lack, less tectonic movements, so it's get blocked. The convections that get blocked within mantle, so that's why it couldn't able to come out and form a magnetic field, a strong magnetic field, and that's the reason why it's weaker. And thank you so much for for this opportunity. And if you have any questions, you're most welcome to answer. I would happy to answer your questions. Thank you so much.
Thank you so much, Nakul, for this very interesting presentation. It was amazing. We have a couple of questions, and I'm gonna hand it over to Zena. She's gonna ask the first question.
Sure.
Thank you so much, Nakul, for this very, very interesting presentation. I just have a question about how we can compare the atmosphere on Venus to that on Earth.
So basically, okay, so when we say the formation of, the atmosphere of Venus and Earth is basically a similar type, but the activities taking place and from Earth and Venus, which led to have a different kind of atmosphere at this point. So the atmosphere of Venus, if you compare to the Earth, like the Venus is like the pressure is so high, and it's like so thicker and hotter, and it's full of carbon dioxide, the atmosphere, like it's acidic and also like full with dense clouds. So it's actually like the type of atmosphere is like similar with Earth, but Earth is like a bit like, how can I say it? It's actually like they didn't experience what Venus has experienced, but Earth can also become like Venus if there is anything happens like increase in carbon dioxide or evaporation of water. So in high scales, which led to the UV rays or anything to interact with the dissociated molecules, but still, yeah. So what the same planets? If the carbon dioxide increases, it'll be like in the same field.
Thank you so much, Nakul. The second question would be, why doesn't Venus have seasons like Earth?
Oh yes. So basically, okay. So for a season for Earth, so it determines on two things. One is its orbit, and the other one is its tilt. So the orbit determines how far it goes and how near it goes to the sun. So it determines how much heat it gets and it determines how much heat it gets. So if it's like near to the sun, it gets heated, and if it's go farther to the sun, it gets colder, and that's why we experience summer and winter. And what about the tilt then? So the tilt determines basically so if we experience like in the northern hemisphere, if it's summer, the southern hemisphere will experience winter. So it's basically like the tilt determines the like basically the tilt determines which part is near to the sun and which part is the north. So for the seasons, there's a lot of things which is determined on. And when it's come to Venus, the Venus orbit is so circular, which means it's basically like the Venus is when it's so wherever point the Venus is in, it just experiences the same kind of its temperature or the heat rays from the sun, and also its rotation, because Venus like it has like this the day lasts like for 100 plus Earth days in Venus, so which literally like heats up the planet. So that's why Venus doesn't have season. So, but how the season in Venus probably would be like is probably would be like how a bit far from the sun, which led to like create some temperature difference, not a huge difference. Maybe like if it's a winter, it may be like temperature goes a bit lower, or if it's a summer, it increases, and the spring and the autumn remains the same, like at the same temperature.
Thank you so much. That is very interesting. Well, everyone, you have been listening to the AICO Observatory's monthly TeleTube broadcast, the Astronomy and Astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Zena, Paul, and myself, Camila. Make sure to leave any comments or questions in the comments section of the video and talk to us in the chat right now. All of our programs are free, but if you'd like to make a donation, see our website at yorku.ca/science/observatory/. You can always connect with us on Twitter with the handle @YorkObservatory and check out our website for show notes, content updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in, clear sky, and have a good night.